Jacob Ballinger, and this is me teaching you about nth roots. So an nth root, for example, is x squared is equal to t. This means that x is a square root of t. So another example is x is a cube root of t when x cube root of 3 equals t. So this is the actual definition of an nth root. B is an nth root of x if and only if b to the power of n is equal to x. And a little fact about nth roots is that other than square roots and cube roots, square roots are when n equals 2, and cube roots are when n equals 3. There's no more special names. So for other roots, they're just called fourth roots, fifth roots, and etc. The number of real nth the number of real nth roots of a real number k is the number of points of intersection of the line y equals k, with the power function y is equal to x to the nth. The number of intersections is determined by whether the value of n is odd or even, and whether the real number k is positive or negative, as demonstrated by this graph and also shown by this graph. So when k is positive and it just touches the x-axis and goes back up, it has 2 points of intersection. When k is negative down here and n is positive, or n is even, yeah. So positive real numbers have 2 real nth roots when n is even, and every positive real number has 1 real nth root when n is odd. And every negative real number has 0 real nth roots when n is even, and only 1 real nth root when n is odd. And 0 only has 1 real nth root, just period. So, for instance, -4 has no real square roots because when it's a square root, it's positive. So, even if it was a positive this number, it would multiply itself and it would always be even, because even if it's like -2 to the square root or squared, it'd just be 4. So -4 doesn't have any real square roots.